Welcome to Thurne Battery Week. My name is Martin Evers and I am the CEO of Thurne, and we are very excited to welcome you to this Battery Week session. And this first session, we will kick off with a session from Dr. Andreas Bergfelt. And this is the first session in a series of 5, so we'll have short webinars every day this week. And during the whole week, we will give a comprehensive material that focuses on the key operations within battery manufacturing and recycling. But in this session, Andreas will cover an overview of some manufacturing technologies of EV batteries, and also the markets and some technologies that Thurne can supply. I am the moderator of this session, and the spokesperson will be Andreas. If at some point you would like to be in contact with Thurne and discuss with us more in depth, this is a team that is handling different offices. So Mattias Persson is heading the Swedish team, Jenny Jensen is heading the Finnish team, Rafi is representing Denmark, Andres the Baltic States, and Robert Poland. And you see the email addresses over there. And if you'd like to follow us, we're active on Facebook, we're active on LinkedIn, and of course also on YouTube. Feel free to log in and see what we have cooking. But now, without further ado, I'd like to thank everyone for participating and your interest. And it's time to begin and present Andreas to the stage. Andreas, please.
Great. Thank you, Martin, for this nice introduction. And welcome to everyone. It's nice to have you here. And as Martin said, it's really exciting to have him this week. And we really want to show where we are in this world and how we look at it. A small introduction to the battery. So as you may know, already in 1780, Luigi Galvani discovered the principles behind the batteries. But the story for the lithium-ion battery is much shorter. So one could say that in the mid-50s, they did some basic research on lithium-ion batteries. And then when put together, the patents start to pop out. And this was, of course, triggered by Armand and Hagemühl and Whittingham. And although this was nice research, it didn't come out on the market really in a commercial way. This happened first in 1991 together with Sony, when you got these lithium-ion secondary batteries hitting the market. And this really sparks a revolution, so to say. And as you all know, 2019, they got the Nobel Prize. And this is John Godunov, Whittingham, and Yoshino. It's because they did this development from different point of views. And to the topic is, we want to look at the battery supply chain. Of course, this is about regarding the batteries, the lithium-ion batteries. But when you look at it from an industrial point of view, you need to have the entire life cycle, and especially from Thurne, because our regular companies that we work together with are focused on raw materials and purification of chemicals. And as you know, the lithium-ion battery of today that's hitting the market, mainly for electrical vehicles, are NMC batteries, nickel, manganese, cobalt batteries, and different chemistries of those. So you need to, of course, then target these raw materials and get them. And you need that in order to do the battery material production. Then you take the raw material, the purified materials, and create active materials. And of course, electrolytes, and you need in order to build the battery cells. And to this, you need control systems, and so on and so forth. It's a huge industry. And then, of course, when you have the battery, you need to use it. And what's triggering the market mainly is, of course, then the electrical cars, as you know. But then a big thing of today is the recycling that we are seeing popping up throughout Europe. And so this is our view at it, and we want to cover the raw materials, purification, and then recycling. And we will also in this week look at what we can do when it comes to battery production, and that is the raw material handling. That means contained systems, mixing, slurry preparation, and so on. With this said, some of the basic materials in this battery field is a casing. You need a steel plastic materials, a cathode material. That means, as I mentioned, NMC and different types of those. There are, of course, a range of other different type of chemistries out there trying to grab a piece of the market. And then you have the anode material that is not as much discussed in the general news. You need current collectors, that means a lot of copper and aluminum, and the electrolytes. And here you have a huge mixture. I just shown some of the most common chemicals you use, like LiPF6, and then you need a lot of solvents to make it ionic conductive. Of course, we are looking into solid state batteries, but I think that is a bit forward. You have the polymer type of electrolyte in batteries and so on, but I think it's a bit left until you could have it in a car. With this said, a lot of stuff is happening there. And you also need a binder, PVDF, that could put some problems later on in the recycling step. And we will also talk about polypropylene separators. And to this, of course, you have a huge system that you need in order to control the battery, like the electrical circuit. As you could see here here is how it could look like when you have assembled a pack of batteries. So you realize you need a lot of different materials. You need to source it. The supply chain is big. And of course, when you reach the recycling step, you need to think of many, many things. So just mentioning a little bit about the raw materials. As I mentioned, NMC is the main focus here, but of course you need so many more materials. But when you look at from the European point of view, that means the European Directive, they have a set of raw materials that are critical for the Union. And they state that cobalt, lithium, and natural graphite is part of these raw materials. And they all go into the lithium-ion battery production. So what does this mean? Yeah, what that means that if you look at the slide here, you see cobalt is mainly sourced from Congo. And that's a bit of a problem. It's an unstable area, makes it rather fluctuating what you get. It gets rather expensive also. So one plan here is to do a lot of recycling, because then you take in the raw material on your market and then you could have it running in your market. Lithium you get from Chile, Australia, China, and natural graphite, as you see, is a lot in China. And with this said, as you can see, much of the raw material handling is located to China. This means that this is a bottleneck. It's a strategic bottleneck. I mean, China is controlling much of this market. They are far ahead of us when it comes to production and recycling. So Europe doesn't have that much, but I would say that we in Norway, Finland, and Sweden have come quite a bit, because Finland is very good at the recycling of especially cobalt. They do have some lithium, and in Norway we are good at refining nickel. So it's a very strategic market to place your industry in the Nordic countries. And with this said, we can look at this chart. It's a very nice chart for the European gigafactories. So in Europe, we don't have the factories yet. We don't have really the raw materials or the refining or the recycling. So you need to start somewhere. And we are pushing a lot on building gigafactories. As you can see here, we got Northvolt, of course. Everybody knows about them. They're out in the news, establishing themselves with a R&D factory here in Västerås, and they got the gigafactory up in Skellefteå, strategically placed with Boliden and other type of companies. But one should also know that Freyr, Panasonic, and Morrow are about to establish themselves in Norway. And this is, of course, very interesting for our market, for the Thurne market. And in Poland, LG is also about to establish themselves with a factory. Then one could wonder what's happening in Finland. Well, as I mentioned, this is just a brief look at what's going on in Finland. Maybe there's no gigafactory on its way, but they have realized that the raw materials refining and recycling is rather important. So you could see they are very focused on cobalt, copper, and so on. So this infrastructure also needs to be set in order to make a sustainable supply line for the battery factory in the Nordic countries. So what's triggering also the research for the batteries? This is the basic principle of how a battery looks like, a lithium-ion battery. It's due to energy density and power density. If you want to have a lot of energy and you want to accelerate it quickly out from the battery. What's also sparking it, you want to fast charging. And this puts a lot of chemical effort on the battery so that you end up with different type of chemistries. You got the lithium cobalt oxide, you got LFP, lithium iron phosphate, you got nickel manganese cobalt, and so on and so forth. This one is the one, the NMC is the battery that is pushing the market. But there are actually other type of chemistries out there. And the future is looking for high energy NMC, different compositions of these materials in the NMC battery, also looking at silicon in the battery or lithium sulfur, lithium air. One interesting thing is that you don't need to use lithium for everything. You could also look at something totally different. That is, for example, sodium-ion batteries. And as you could see, the chemical formula for a sodium-ion battery is sodium, iron, and cyanide. This means it's, if you compare it with cobalt, that's rather toxic. This is a very safe, environmentally friendly type of battery, although it's a limited usage because it doesn't have the same capacity as lithium and is rather not as mature. But one interesting company we have here in the Nordic is Altris. Of course, you have other companies in the UK and France and of course China. But this is a local company producing active materials for our industry. But, okay, that was a little bit of the background for the raw material supply chain. Now we're looking at the battery production. As I mentioned, we're not, Thurne and our suppliers are not focused on really the core of the battery production. That means automation and blah, 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 blah. We're into the material handling, containment, and slurry preparation. That is the first step in the production. Of course, super important in order to get the material homogeneous when you're coating the electrodes and with the right quality. But as you could see, you need the coating, drying, calendering. This is just some of the stages, not at all the entire production line. Slitting, vacuum drying, but we also do from Copernic and Day, we do electrolyte filling of the batteries. So bear this in mind, but they will present this in detail later on in the week, the formulation and mixing and electrolyte filling. And then you've got welding, packaging, and then of course you need to set up it with cell formation, the gassing, aging, testing, and a control unit to the battery. So it's a huge industry we're talking about. And we are targeting the beginning of it and the very end. So with this said, we got the active materials. This is how we will talk about later on, how we're feeding it, dosing it, mixing it, so it becomes fully homogeneous. And depending on what type of, these are the common materials you are using, but then of course you have a lot of additives that are top secret for the producer. What you need to know also for the future is the battery directive. So European Union got this battery regulation, but it will change in the future, in the near future. And what does it say? It says that you need to be able to recycle the battery to a certain content, and that the battery needs to have some amount of recycled material in them. So this puts up a huge pressure on every country, of course, because this has to be applied in all European Union countries, and this will affect the battery producers. As you could see here, it's specific lithium battery material recovery rates. Cobalt is rather easy to recycle, nickel, but lithium 70% and copper, you realize you need to have a plan for this. And this puts us to our presentation on Friday from Andreas and the Directive process systems. We will focus on mechanical and chemical recycling. So the mechanical step is rather easy. You crush it and you sort it. You end up with a black mass, all the expensive materials inside, the cobalt, graphite, nickel, manganese, so on and so forth. And then you need to do chemical hydrometallurgical recycling. You need to do leaching. Then you need a lot of acids, mostly hydrosulfuric acid. That's why we're giving a presentation about recovery of this chemical. You need to purify it, and then you need to recover your raw materials that you could see is cobalt, manganese, and nickel. And depends on so many questions how you set up such a factory, so we can't do it in one day. So that's why we're just focusing on hydrosulfuric acid. Depends on which type of grade you want to reach and what market you want to reach. You can't just take them and put them in the battery again, because most certainly the purity won't be good enough. Battery production, you need 99.58 something. But also, there's a lot of money to be earned in this recycling. As you could see, lithium-ion batteries placed on the global market between these years is a huge amount. So you need to have a clever and very good approach for the future when it comes to recycling. This will be big scale. And just to give a feeling for how it could look like, you send in black mass, you need to do leaching, hydrosulfuric acid, and other chemicals, and filtration. And then you need to take out what you want. You need to define what type of chemicals you want to take out, because it's hard to go for every single bits and piece of ion in this solution. It won't make the money for it. So you could realize these steps are in, this is just a general flow chart. Filtration could maybe be 1, 2, 3, 4, 5 times, and so on, and you back circulate everything. But you need to define what you're taking out from it. And this will help you with discussing, because now we will talk about Thurne and what we want to show you and what we could help you with. So this is Thurne. It's owned by Adtech. We got offices in the Nordic countries here, in Stockholm, of course. In Finland, we are present in the Baltics, Poland, and Denmark. Our expertise is powder handling, reactor systems in corrosive environments, on the separation and drying on all the components. So this is a very good general picture of what we are doing for type of chemistry, or which type of industry we are targeting. Here are our main brands. So we will present the Directive process systems. They contain Rosenmund and QVF. This is the same company. We will talk about Andreas separation and recycling, Lödge mixing, and then DEC and Coperion with the powder handling. But as you could see, we got several other suppliers in our portfolio. So a lot of information in one slide. It's just to show you a deeper, this is what our standard business case is: powder handling, milling, sieving, reaction technology. Even if you need one reactor or a system, then you go down for engineered systems. And we are specialists in acid handling, as you will see on Friday. We got different type of filtration techniques for pharma or bigger raw material type of filtration. And reaction technology. If you want to go into recycling and you want to do solid liquid or liquid liquid type of separation, we got materials for that. So just to narrow it down a little bit, we are talking about Thurne business area, mining and mineral. Those are listening, you know us most certainly that are in this field. It's a traditional field, but we see you, and we see an activity, an increased activity on the market. And we understand that many of these projects are coupled to the battery supply chain. So we realize this and we want to talk about this. The same when it comes to corrosive process environments. I mean, of course, a lot of these materials are corrosive, and this is why we got these type of materials for this application, study glass line equipment, specialty hastelloys, PVDF lined materials, and so on and so forth. And the chemical, what does this mean? Yeah, when you're doing active material handling, producing active material, you need a process system with a contained environment. So what's new for us is the active material handling and recycling. And that's why we want to have this week. We want to present one supplier each day. And we're very proud and happy that Coperion Catron, Dec, Lödige, Andreas, and Directive will show you what they are doing in depth. So Coperion, we will talk about material handling, the transport, slurry preparation. Dec will cover basically the same, but also with this contained system approach to keep the powder at place, and also on a system level discussion. This will also happen with Andreas, that will cover in a very thorough way the mechanical recycling of batteries, also on a system level. The Dietrich will cover the acid recovery systems.
Good. Thank you, Andreas, so much for your presentation. And I still want to remind everyone that there's tomorrow's session about battery mass and slurry production. And you can register to that through our web pages. Thanks to everyone. I wish you a very nice and pleasant start of the week, and hope to see you in the other sessions later this week.
Great.
Thank you so much.
Thank you very much. Bye-bye.